Hello everyone. So let's start with our today's topic, that is Apache Kafka. So it's a very important topic and this one shot is for beginners and those who are experienced also, they can also go through this, but I have ensured that this should be friendly to the beginners also. So Apache Kafka is an open source distributed event streaming platform. What does this distributed and what does this event streaming platform, everything you will get to know in this lecture. So let's take a simple example. Like you are a person, you want to send a message to your friend. So you are using any of the social media website, let's say WhatsApp you are using. So you are the sender and one will be the receiver. And you will be texting some message and at that same real time the message will be received by your friend. That's just a small message you are sending, but there can be lots of data, huge data, which we need to send from one place to another or one producer to another consumer. So that's why we use Kafka. Basic terminologies and everything I'll discuss later. So first of all, we'll go through the slides. Apache Kafka is basically where we collect our data. Using Apache Kafka, we store our data, we process our data and send our data in real time. So it is basically a real-time data pipeline which continuously moves data from one system to another reliably, fast and at scale. Think of a Kafka as a huge newspaper printing and distribution system. Okay. The producers will be the reporters. And what is the role of Kafka is to print and store and as a distribution hub. Like the news they are printing, they are storing the news and they are responsible for even distributing those news. To whom they'll distribute? They will distribute it to consumers. From where they'll get the news, they'll get it from the producers. So keep in mind, we'll go through all these things in detail also. So I was saying, what is event streaming? So first of all, what is event? Event is anything that has happened or something that has happened. For example, user clicked a button, that is also an event. For example, order was placed using Swiggy, Zomato, or whatever websites you are using, or Flipkart, Amazon, anything you are placing any order, that is also an event. If you are trying to do any payment and the payment is getting failed, that is also a kind of event. There are different kind of events and Kafka is built to handle million of such events per second. Kafka handles so many events at a time. So why Kafka works so fast? So why it is working so fast? Why everyone is going to Kafka now? So because it doesn't write its data in cache or something. It's sequentially writes data on disk, and also it retains the data for a large amount of time. We'll discuss all these things. As soon as the producer will produce some message, it will go into its memory sequentially and the consumer will sequentially consume the data from the disk. Okay, that's why it is so fast and everyone is moving towards Kafka. But when Kafka was not there, what all things we were using? We were using databases, we were relying on batch jobs, like we used to process them either daily or weekly, and there were some messages queues which were used. But there were a lot of problems with the old system because there are the chances of data loss. They were not that much scalable. And if our data is lost, it is very difficult to regain our data. And there were many more disadvantages that the batch processing which we used to do initially, we need to create the batch of different sizes and then process that data, and that takes a lot of time. So we do not use those methods. Then Kafka came, and Kafka's biggest advantage was real-time data processing. For example, you are using Rapido, you are using any Uber, Ola. The real-time location you are able to see is because of Kafka only. And it gives high throughput. Throughput is that the millions of events it is able to handle in seconds, and multiple customers read same data. And also it is fault tolerant. If either one of the, I'll say, like for example, you can think of it is a server. If one of the server fails, a whole of the data will like you will be able to work upon your site will won't get down because of Kafka, because it has multiple brokers. From one broker to another it will switch. One is the leader always, and others are its replicas. We call them as follower. We all will see later in this tutorial only. So where Kafka is used, I told you that in Uber, Amazon, Flipkart, Netflix, Uber, you can see there are so many use cases of Kafka because of its main reason was real-time analytics, real-time data transfer, and high throughput. And even the monitoring is so easy using Kafka. So this is the basic architecture and workflow of Kafka. What is done here? Producers are, you can think of that WhatsApp example that you are the producer who is pushing some message into the Kafka cluster, and consumer is your friend who is taking the message or consuming the message or pulling this message from Kafka cluster, and there is brokers in between, and there in brokers we have different topics, and inside topics we have different partitions. From basically these partitions these consumers are getting the data. We'll see everything in detail. So high level architecture is producer is producing the data. Using the Kafka broker, it is reaching to the consumer. And in Kafka broker, main role is of partition. Partition is inside topic and topic is inside broker. Okay. Producer will send message, Kafka store message inside topics, data is split into partition, consumers read data independently. And Kafka does not delete data after consumption. So it is the good advantage that once your data will reach the consumer, then also Kafka will not, the producer will not delete that data. Otherwise, in the traditional methods, what was the things like if you have shared some data, once the receiver will receive that, and after that it get deleted, and it is very difficult to take that data back. So Kafka does not delete data after consumption. Also, consumers can track their own progress. So we talked a lot about what is producer, consumer, and all. So what are they actually? Producer is someone who sends data to the Kafka. And for example, mobile app sending user clicks is a kind of event that producer does and sends a data to our application. Consumer is someone who reads data from Kafka. Okay. Broker is, I told you na, server. Broker is Kafka server only. It stores all the data. And a Kafka cluster is composed of multiple brokers. And in brokers, we have some topic. Topic is the logical category to store message. Inside topics only we store the message, and there is one thing partition inside the topic where the actual message is stored. Okay. And now here is the partition. Topic is divided into partitions which enables parallel processing, and message inside a partitions are ordered. For example, you can see here there is a partition 0, 1, 2. It is inside the topic names order. So in this partition, for example, here is partition 0, 1, 2. This 1, 2 is the offset, which is the unique ID used to identify which it is helpful for the consumer to get an idea to get that what data the consumer wants from which producer it wants. So these are all offsets, this 8, 1, 0 and all. And what is the partition logic? Like here I told you this is partition 0, 1, 2. So this question might come in your mind. How we are partitioning these? So there is a concept of key. So this method we basically use. If key is provided, then we use this method for the partition. And if key is not provided, then the round robin method will be used. But in round robin, we have the better load distribution, but ordering we can't guarantee. Lekin, same key means same order preserved. So whichever is your use case, depending on your use case, you can use the partition logic. So here is the offset. I told you that 0, 1, 2 or 12, 8 and above. These were unique ID to each message in a partition. These are helpful for the consumers who use offsets to track their process. Now, one thing is consumer groups. Consumer groups name suggests a group of consumers. Multiple consumers who work as a team is known as consumer groups. Each partition is read by only one consumer in a group. Okay, it enables scalability. For example, there are three partition 0, 1, 2, P0, P1, P2, and here are three consumers. They might be in same group. So if we combine ABC, they will be called as consumer group. See, offset, I told you this numbers offset consumer to group 1. Now, How Kafka stores offset? Kafka stores offset in a underscore underscore consumer underscore offsets name of internal topic. This is the internal topic of Kafka where all the offsets are stored. And there are two modes by which we can commit our offsets, that is auto commit and the manual commit. In auto commit it is very easy and the risk of data loss is there, but manual commit is recommended because it is more safe and controlled, and this is basically recommended for production, and we should go for manual commit instead of auto commit. The way to do auto commit is directly pull auto commit, the process will get auto committed, and here is the risk of data loss. And for manual commit we'll have to do this and there won't be any data loss. Now these are two servers, server 1 and server 2, or we can say these are two broker 1, broker 2 inside the Kafka cluster, and we have these partition, 3 partition here and 3 partition here. So this is the consumer group A which consists of 3 consumers, and this is the consumer group B which consists of 3 consumers. So here what all things are going on, that consumer is getting some data from P0, is getting data from partition 2 and partition 0, and C1 is getting data from partition 3 and partition 1. So this way these consumer groups are getting data from different servers and different partitions. So on a higher level you can see that these are producers, here is the consumer, here is the, I told you about leader, I told you about copy or follower. This keep this diagram in your mind, I'll tell you everything, what is zookeeper and everything I'll tell you in detail. And what is replication leader follower ICR, so ISR, sorry. So first of all, replication factor is how many copies of data you want. For example, here the copies of data like partition 1, copy of partition 1 and copy of partition 1. So here the replication factor of partition 1 is 3. Partition 2 leader is this and these two are copy, and the replication factor of this is 3. Leader handles read and write. Leaders will be always active, handling all the read and write operations, and followers are always the copy of leader data. And ICR is in sync replicas, which are healthy followers. For example, if there might be chances this partition 1 leader got like crashed or some fault is there, so what will happen? It will go to broker 2 partition 1. This copy 1 partition will become leader, and this will now do read and write operation. And this partition, out of these two, why we chose this partition is based on in sync replicas, that this has the potential to be uh, healthy followers, so we have gone for this, and in this case we ensures that no data is lost. Okay, so the in sync replicas followers that are fully caught up, only ISR can become leader, others can't be leader. This is also like this is leader and this is their follower, or you can say the copy, and it's always inside different brokers. You won't see any case in which the leader is in broker 1 and its follower is also in broker 1. No, this can't be the case, because treat them as different servers. If there will be one different copies of same thing in one server and this server get crashed, this broker get crashed, then there is no point for fault tolerance. So that's why we keep them always in different servers. Now you can see we have this is also the same diagram. You can see these are the brokers, these are the partition 1 2 for all. This is called as 3 node Kafka cluster. We can say the topic name is XYZ. Here is the partition leader replica. This is partition leader follower. This is follower. Okay. See, this will do all the read and write things because this is the leader. Others are followers. So they will do their work only if this server gets crashed or this server faces any issue, then only it will go for the followers. Okay. So Kafka cluster, you already know that, which contains multiple brokers, data is distributed across brokers, and which handles automatic failover. For example, in Kafka cluster, broker 1 got some fault, so it will turn to broker 2, and this all things are done with the help of Zookeeper. We all will see later. If one broker crashes, another takes over. Okay. So here also you can see there are some producers, and these are the topics, different topics, topic 1, topic 1, topic 1, topic 2. Inside different there are different partitions inside the topic, and once this went, like consumer will consume the data from the partition it wants, and it is all done with the help of Zookeeper. So now I'll tell you what is Zookeeper. Zookeeper you can say as the manager of the Kafka. It was a very useful utility, without which we were even unable to run Kafka. But now there is the different I'll that something craft, Kafka Craft. Sorry, Kafka Craft is there, which has overcome the advantage and disadvantage we can say for this. So this Zookeeper is the manager of Kafka, who uses to coordinate everything from broker coordination to leader election to metadata management, to who will become the follower. Like if the leader broker got crashed, then which one will be the follower working. That all things Zookeeper needs to handle. It's kind of referee managing the Kafka game. New Kafka version are moving towards KRaft. I told you na, KRaft is the thing which has replaced the Zookeeper. So what problem Zookeeper solves? Initially, we know Kafka is a distributed system and many broker servers work together. But in distributed system, to keep track of which broker is alive and decide which broker will be the leader, and everything will be coordination and everything will be done by Zookeeper. So the brain plus referee of the Kafka cluster is Zookeeper. You can remember it like this. What Zookeeper does for Kafka. Now, all know, we have seen those things only. These are the same. So what Zookeeper does not do, it does not store any Kafka message. Some people might get confused, but this is not done by Zookeeper. The storage thing is not up to the Zookeeper. It does not handle any producer or consumer. That is handled by brokers only, topics only, and the partition only. The data is actually carried by them only, not by Zookeeper. Why Kafka needed Zookeeper? Because brokers were dumb. They don't know whether if one will get crash, whom to shift and how to shift. So they are dumb. For that only Zookeeper came into existence, who handle all the coordinations and who become leader, who is alive, who should take over if someone dies. Is everything handled by Zookeeper. Why not without Zookeeper? If Kafka could not run without Zookeeper, because there is no internal way to manage metadata, no leader election logic inside Kafka, so Zookeeper was mandatory. But now if you will use KRaft, then you need not to use Zookeeper. And still, after coming KRaft, Zookeeper based Kafka is still widely used in many of the companies. Zookeeper coordination with Kafka. See, it is directly coordinating with the broker, so it knows if this broker will fail or some crash will be there, then it will redirect it to someone else broker. This you can see, this is a cluster, Kafka cluster containing different brokers, and each broker have different topic, different partition, and the consumers are consuming the message from different topics they want, and the Zookeeper is taking care of. It has a connection with the producer also, it has a connection with the consumer also, and with brokers also. This is the basic operation, that a producer is sending some message via topic and partition through broker, and consumer is consuming that message or reading that message from a topic and partition. Now what is the producer internal flow? Producer internal flow is, we just know that producer is sending the message. Now how the app code is working, when the message is sent, how we'll know that the message has been sent to the topic or the broker? Then there is the concept of acknowledgement. If the acknowledgement is 0, then it is like very unsafe, and if it is 1, then there might be the loss of some data loss, and if it's all, it means it is safe and the whole data has been transferred correctly and successfully. See, if acknowledgement is 0, so it is the first of all, it is the fastest way, and producer does not know if the data was written, because there is a high chances that data will be lost. So this is considered as very bad acknowledgement. We don't consider it as good acknowledgement. Acknowledgement 1 is good performance. There we it can lead to, like, this is the default setting we can say, and there are very less chances of loss of data. If leader crashes before followers copy, data loss is possible in that case only. And if acknowledgement is all or -1, this we consider as strongest guarantee that there will not be any data loss and consistency will be there. It will be little bit slower, but this is the best acknowledgement by the producer. Producer retry and idempotency. Without idempotency, retries can cause duplication of the messages. Like if you send some message hi, it might go twice if there is idempotency. So with this, what it ensures, Kafka ensures that duplicate messages will not be there and safe retries will be there. So there is one flag which we need to write enable dot this is equals to true. Now there is topic. Inside topic we have partition, and inside partition we have segment, because I told you that we are writing messages directly on the disk. Real storage is there. So this way the message is getting written in the disk. It is doing sequential disk write and it is very fast, and it is doing OS level optimizations. And if I talk about consumer internal flow, so you should be aware about consumer group rebalancing mainly. For example, if consumer C1 joins a group, partition will be assigned to that from where it will consume the message. But what if between that consumer C2 joins? So there we need to stop and then rebalance the trigger and reassign the partitions. Then only the consumers will be able to consume the message. But these are very expensive, and if there are so many consumers, we don't consider it a good thing. So actual steps is they usually pull the data, send fetch request to broker, then broker will read the message from disk, then broker sends batch of records, then consumer processes those record and commits those offsets. Commits is done so that they should track their progress later. I told you, they are able to track their progress. That's why they made these commits of offsets. Now this replication and failure scenario, for example, this leader got failed. So follower 1 will become the leader and there won't be any downtime. And this replication has saves your data. Retention policy is that how many days our data will be there after the consumer has consumed our data. So if it is time based, then 7 days retention. If it is size based, then it will be 100 GB per topic, and 100 GB is so large. So there are some common operations. To start a Kafka, we should move to this server start.sh file. Then we should open this server properties file inside config folder. And to create a topic, we need to use --create --topic. Orders is the name of the topic, and inside topic how many partitions we want and what is the replication factor, like how many copies will be there for that. In total 2 copies will be there. Produce message, so where we want to produce, in produce.sh we will write that in topics order we want to produce our message. And consumer, how it is consuming, from beginning it is consuming our messages. So there is one more way. If you will use this backslash, then it will move to next line and you can write your commands, or you can say steps there also. And this is the server which you are using to create a topic, and the producer which is producing is also using this server, and the consumer who is consuming the message will also use this server only. When not to use Kafka? Now this is the great question. When you have very low volume of data, then you should not use Kafka because it is made for huge data. If you need only request response, then there is no point of using Kafka. And if you require simple queues, then it's better to go with traditional methods instead of this. And if you have no use of real-time data, then don't prefer it. Now how to install it? First of all, you should have Java 8, 11, or everything, whatever JDK you want. Then you should have Kafka. Then you should start Zookeeper first. After that you should start Kafka server, because without Zookeeper you won't be able to run Kafka. Then you need to create topic. Then you will send some message via producer and consume the messages via consumer. Java, these are the steps that you can check if Java is already there in your system. If not, you can install it and then add the environment variables in your system. Then you can add the path. And Kafka download already contains Zookeeper, so you need not to install Kafka and Zookeeper separately, you can directly go to this website and download Kafka. You can choose this option to download it, or you can use the zip file and extract that. And this is the basic Kafka structure. You have bin directory, then you have config directory and logs directory. So to start Zookeeper, Kafka basically depends on Zookeeper. So we should start the Zookeeper like using this command, and you will see an output like this. This will indicate here that your Zookeeper is running. And if you want to start Kafka Broker, then you need to open the new command prompt. You cannot use the same command prompt, so prefer to use a different command prompt. Then startup order, always remember, first of all Zookeeper you will start, then Kafka Broker you will start, then only you will start the sending the messages. So if Zookeeper is down, then Kafka will refuse to connect. So verify Kafka is working or not. You can verify by creating a topic. I told you above only how you can create the topic and then partition inside that, then the replication factor and all. Then producing the message like you typed hello Kafka, then it will be consumed there, and you will see that hello Kafka is getting consumed by the consumer. Failure scenario can be there that broker 1 dies, then Zookeeper detects missing heartbeat, then Zookeeper elects new leader and Kafka continues to running. The difference between Zookeeper and Kafka is Zookeeper works for the coordination and Kafka is mainly for data streaming. And while data streaming, inside Kafka only, we have the broker, and to coordinate all the brokers, we need Zookeeper. Zookeeper basically stores the metadata and Kafka stores the messages. Zookeeper is basically responsible for leading the like who is the leader, who will be the follower, and if a leader is failing or some fault is there, then who will be the next leader who will be taking over the control of the server, and um, downtime will not be there. It will be the responsibility of Zookeeper. Now what Kafka guarantees that message will remain in the same order if we are using the partition with keys, and if we are doing round robin, then the ordering can be changed. And durability, that disk storage is there, fault tolerance is there, exactly one processing and at least one delivery is there. So you can see and yourself the differences between traditional method and the Kafka. The Kafka is much better. Real world example is, if you are, I gave you already before so many examples, but you can go through it. If you are placing any order, then producer will send a message to the event name orders or the topic named order, then Kafka will store that event and payment services will get consumed, notification service will consume it, and analytics system will consume it, and all these things will happen. You can see this diagram. For this newspaper example I already gave you, if a reporter writes some news or printing press stores those copies and readers read anytime. This is the producers, this is the brokers or the topics which stores the copies, and readers are the consumers. Consumer group is there. So in consumer group, there are three consumers, C1, C2, C3, and these are taking data from different partitions. More consumers than partition means if there are two partitions and consumers are more, then the third consumer will stay idle. Multiple consumer groups are very powerful. Same message delivered to all groups. Okay, independent offsets will be there, and it is very useful for the monitoring and analysis purposes. What happens if consumer crashes? If consumer C1 P0 crashes, we heard that if producer will crash, Zookeeper will help, and Zookeeper will do all the things and shift it to another broker. Likewise, if Kafka detects heartbeat failure, will rebalance the consumer. Rebalancing, I told you consumer rebalancing how to do. Then the partitions will be again assigned to the consumers, and this we consider as bad because consumer should not get down. Real world example of orders I gave you already, that it will go to validate payments, notification and all. Now KRaft. KRaft is, we can say, Kafka Raft metadata mod. It's Kafka built-in way to manage the metadata and cluster coordination without Zookeeper. There will not be any role of Zookeeper. And why Kafka needed KRaft? Because every time we were using the Kafka, we need to start Zookeeper first. So there were operational complexity and harder scaling and upgrades. So we went to invent this Kafka KRaft, which track the borders, who is alive, broker, sorry, who is alive, and elect the leaders, and everything what Zookeeper was doing is now done by KRaft. KRaft removes Zookeeper and puts coordination inside KRaft itself, but still many of the companies are using Zookeeper only. How KRaft works? So KRaft uses the Raft census algorithm to agree on metadata. It has some components, say controller, quorum, metadata log, and draft. Okay. What runs in KRaft? Controller nodes handle broker registration, leader election, topic creation, partition metadata, and what broker nodes handle? Message storage, read, write, and replication. But Zookeeper was never storing the messages, it was just taking care of the coordination. A node can be both controller and a broker. Here you can see in diagram also. Earlier old Kafka uses Zookeeper, now it is not required. External coordinator it was, but it is built in Kafka because we need to restart our Zookeeper first. Then we used to run our Kafka, but here it is not so. We can only run the Kafka. Znode metadata and Kafka metadata log. It uses this Zookeeper leader election and it uses Raft census algorithm. Now, KRaft versus Zookeeper, these are more differences that Zookeeper require, and it is complex setup that is simple. KRaft is better because new things comes with some upgrades and some benefits, and you can go through them later. And so, quick revision. Kafka is a real-time data streaming platform. Producers are sending the messages to brokers, and via brokers, it is going getting consumed by the consumers. Topics and partitions enable scaling, which are present inside the brokers. Consumer groups are enabling parallelism. At the same time, different consumer groups are able to get the same data and they can work upon the same data, read and write operations. Replication ensures fault tolerance. Zookeeper manages Kafka. It is widely used, and one line memory tech is real-time scalable fault tolerance data pipeline is known as Kafka. The final revision is Kafka. There is one thing producer, topic, inside topic we have partition, inside partition we have offset, and one is broker, consumer, and consumers are inside consumer group. We have different consumer groups, Zookeeper, KRaft, and replication. That's all. So you can go through this PPT later if you want. If I can provide you this PPT. And thanks all. Please do like, subscribe to my channel, and if you like my teaching, then please comment out should I make other videos like this on some difficult topics. Thanks. Bye.